Thanks to Brilliant for helping support this episode. Hey Crazies, we're made of matter, which means we experience time. But what if we weren't made of matter? What if we were made of something timeless, like light instead? What would the universe be like for us? This episode was made possible by generous supporters on Patreon. Okay, so stuff in the universe generally falls into two major categories: matter and light. What separates them is their rest mass. Matter has it, light doesn't. But categorizing things by their mass can be problematic because mass is not a fundamental property. It's an emergent property. It appears out of the interactions between particles, out of the ensemble. Seriously, consider something extreme like a black hole. You've probably heard of black holes eating entire stars. But they don't just eat matter, they also eat light. Light is massless, but if a black hole eats some, it'll still grow. The light has become massive just because it's trapped. We call it confinement. Mass emerges from that confinement. For that matter, you don't even need the black hole to begin with. If you get enough light in one place, it'll become a black hole all by itself. It's called a Kugelblitz, a ball of light. A massive ball made entirely of massless things. And a similar thing actually happens inside your body. Almost all of your mass comes from the protons and neutrons at the center of your atoms. About 99% of that mass is from massless gluons, just because they're confined to a space about 1 femtometer wide. My point is, you're already made of massless particles. They're called gluons. Making you out of massless photons instead wouldn't make much difference. If they're confined, the collection will still have mass, which means you'll still experience time the same way. Yeah, but what if those millions of photons aren't confined? Then you're not a single object. Okay, then what if I'm made of a single photon? I see you're not gonna let this go. Fine. I have no idea how a single photon could give rise to the complexity of conscious thought, but I guess we're gonna let that go for a few minutes and see what happens. How does a single photon freely moving through space experience the universe? Being a photon, you can travel at the speed of light, and that's not something our current selves have a lot of experience with. Humans spend a lot of time sitting still, but we do move around sometimes. We walk at about 3 miles per hour and run at maybe 8 miles per hour. In a car, you might be moving anywhere between 30 and 70 miles per hour. In a plane, you could easily be going over 500 miles per hour. The fastest any human has ever gone is about 24,800 miles per hour. But that's all peanuts compared to light. Light travels at 671 million miles per hour. Light goes so fast that no human could ever catch up. Fast. For this to really sink in, we need to consider the concept of momentum. If you're not moving at all, your momentum is zero. The faster you move, the bigger your momentum gets. It's a nice, simple, linear relationship. But like with most linear relationships, this one has its limits. It only works well for slow speeds. This range is where the error is less than 1%. The fastest humans have ever gone is only 0.004% the speed of light, which is well within that range. In the realm of human experience, that linear relationship is fine. But if you're traveling anywhere near the speed of light, the error grows exponentially. If a human traveled at exactly the speed of light, they'd have infinite momentum, which is completely ridiculous. Then how can light go that fast? By not having mass. Remember all that mass talk at the beginning of the video? Yeah, it wasn't just filler. According to the standard model, a photon has 0 rest mass. To understand why that matters, we need to look a little closer at that momentum. The equation for momentum from special relativity has speed in it twice. One on the top of the fraction and one on the bottom. We have to watch both. As a human approaches the speed of light, the bottom of the fraction approaches 0. As a result, the momentum approaches infinity. But that's actually only true if the top of the fraction is a normal number. In our case, the mass of a human times the speed of light. Massless particles like photons found a loophole to this problem. The indeterminate form. That's when some combination of 0 and infinity can unexpectedly give you a finite non-zero number. The standard indeterminate forms are 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the 0 power, and infinity to the 0 power. That first one is the loophole photons use. It might be okay to have a 0 on the bottom of a fraction, as long as you also have one on top. Photons do that by having 0 mass. That's what allows them to travel at the speed of light and not have infinite momentum. A 0 mass gives us 0 over 0, an indeterminate form, and the result is a finite, non-zero momentum. Kinda cool, huh? Anyway, some weird stuff happens as you approach the speed of light. Length contracts, time dilates. It's crazy counterintuitive, if you're unfamiliar with it. And not only that, those effects are relative. As we watch this accelerating rocket shrink in length and see its clock slow down, any passenger on that rocket will see the same thing happen to the rest of the universe. The entire universe will contract along the direction of motion, and it will take more time for things to happen in that universe. But remember, the rocket can never actually reach the speed of light, so time will never actually stop. The clock will always be ticking forward, just extremely slowly. But a photon can go at exactly the speed of light. I mean, it can't go any other speed. Plugging any other speed into this equation would make a photon's momentum 0, which means it wouldn't exist. Photons have to travel at the speed of light or they don't exist, and that has relativistic consequences. If you take this effect to the extreme limit, the universe will flatten to 0 thickness, and time will dilate to infinity. For a freely traveling photon, the moment it's created is the moment it's destroyed. And those events happen at the same place, which is the only place. Nothing would be happening in the surrounding universe, because the surrounding universe wouldn't exist. So what would it be like to be made of photons? Well, if you're a collection of photons, everything is basically the same. The confinement of those photons would still give you mass, in exactly the same way your gluons already do. You would still experience time. But if somehow you were a single photon freely moving through the universe, that's when things get weird. As massive things approach the speed of light, the rest of the universe shrinks and slows. As a single photon, you would take this effect to its inevitable limit, and the surrounding universe would cease to exist. Photons don't experience anything. Photons are timeless. So, would you want to be made of light? Please share in the comments. Thanks for liking and sharing this video. A special thanks goes out to Patreon patrons like Matthew O'Connor, who's been supporting us at the Asylum Counselor level for over a year. Wow, that's a lot of support. Don't forget to subscribe if you'd like to keep up with us. And until next time, remember, it's okay to be a little crazy. Do you want to learn something new? Well, Brilliant is the place for you. It's a website and app that makes learning accessible and fun. Brilliant's courses are laid out like a story and broken into pieces, so you can tackle them one bit at a time. And there are over 60 of them, so there's something for everyone. Brilliant's Calculus Fundamentals course begins with a quiz on indeterminate forms, and is part of one of their learning paths, a collection of courses that help guide you in a particular direction. You might also like their Special Relativity course, which has quizzes on photons, tachyons, and causality. Brilliant's approach is based on problem solving and active learning. It's about seeing concepts visually, interacting with them, and then answering questions that make you think. If this sounds like a service you'd like to use, go to brilliant.org/scienceasylum today. The first 200 subscribers will get 20% off an annual subscription. Wait a minute. How can galaxies travel faster than light? Well, they're not really traveling that fast in their local space. It's just an illusion created by the expansion. I'll elaborate in a future video. Anyway, thanks for watching.